This lesson will consist of 3 topics. We will start with completing the square. We will then learn how to solve quadratics by taking square roots. And then finally, we will put the 2 ideas together by completing the square in order to take square roots. So this is a 3rd way to solve quadratic equations. You should only watch this video after you've practiced the first 2 methods of factoring and using CPP, and then solving by quadratic formula. So the first lesson, let's get started on completing the square. So to complete a square, we first need to go back to what does it look like when we square something. So if I square the expression x plus 2, I could use this area model or box method to help me do this. I would have x plus 2 on both sides so that I am multiplying x plus 2 by itself. That gives me x squared plus 2x plus 2x plus 4, and when I write that in standard form, I get x squared plus 4x plus 4. You should probably pause the video and try the next one on your own, and when you're ready, restart. And if you multiply x minus 10 by itself and rewrite it in standard form, you should get x squared minus 20x plus 100. So now that we know what it looks like to write a perfect square in standard form, we're going to go the other direction. So in each of these examples, I have a square, and I want to be able to write it in both factored and standard form. So I'm going to complete the puzzle. In my first puzzle, I have an x plus 5 on the top, which means my side should also be x plus 5 since it's a square. That's going to give me x squared plus 5x plus 5x plus 25, and my standard form is x squared plus 10x plus 25. In my next problem, I need a 16 here, and I know that these numbers need to be the same, so they must both be 4. Similarly, if I have an x squared here, I need an x and an x here. And now my length and width are the same, making it a square. I have 4x in each of these boxes, and my standard form would be x squared plus 8x plus 16. And then finally, if I know that I need a 7 times x in this box, generally we put the x term first and the constant term second. So I'm going to need an x times an x here to make this square, and a 7 times a 7 so that this side and this side are the same. So I have x squared plus 7x plus 7x plus 49, and my standard form would be x squared plus 14x plus 49. So I can now see that when I write x plus 5 in factored form, squared in factored form, it looks like this, and when I write it in standard form, it looks like this. To write the second equation in factored form, I would say x plus 4 squared times itself. And finally, x plus 7 times x plus 7, I can write as x plus 7 squared. So we call these expressions perfect squares because we can write them as something squared. So now that we know what it looks like when something is a perfect square, we can do something called completing the square. So to complete a square, I am looking for the constant that I would need to add to an expression to make it a perfect square. So if I want to write x squared plus 4x plus something and make it a perfect square, I know that my x squared is going to go here, but how do I put 4x into this area model evenly? We know that this term and this term make up the x term, which means that I need to split this 4x equally into these 2 boxes. So I'm going to put half of 4x in each box, which gives me 2x and 2x. And this allows me to finish out the puzzle. I now know I need an x and an x to get x squared. I need an x times 2 to get 2x, which means that the number that completes my square has to be 2 times 2. So the number that completes the square is 4, and I put that 4 right here to complete the square. I can then rewrite this expression as x plus 2 squared. So this piece right here is the process of completing the square. This is the method that we are learning. Let's check out this second example. I need to complete this square, x squared minus 16x plus something. So the something that I am trying to figure out what to add here is the number that completes the square. Sometimes we write CTS, completes the square. So to find this value, we would again use that area model. We know that this is a square. We know this is x squared, and we need to take this x term of negative 16x and split it evenly between those two boxes that hold the x terms. So I'm really dividing this negative 16x by 2. And when I divide it by 2, I get negative 8x in each of these boxes. And if I know those are negative 18x, I know that on my sides I must have x times x to give me x squared and negative 8 to give me those negative 8x's, which means that to complete my square, I must be multiplying negative 8 times negative 8, which would give me positive 64. So this 64 here is the number that completes the square. So before we move on to solving quadratic equations using this method, we do need to go back and talk about how we solve by taking square roots. So if you'd like to try one of these examples by yourself before you move on, here is a great you try problem that you should try before the second part of this lesson. So at this point, you should have tried to complete the square on your own. You should have gotten 25 for that last example problem. And you're now ready to review how to solve quadratic equations by taking square roots. So many of these problems you'll be able to do in your head, and we are going to take advantage of some mental math to review this method. If you have not seen it before, you did learn it when you learned what it means to square a number. It just has a new name. So our objective is taking the square root of both sides to solve the equation, and this will set us up for the completing the square method. So the idea is if we use mental math to solve this, we're saying if something squared equals 1, what is that something? Well, I have two options. X could equal 1 or x could equal negative 1. In my second example, if something squared equals 4, well, 2 squared equals 4, and also negative 2 squared equals 4. You can go ahead and pause the video and try these next two yourself if you want to make sure you understand it. And then when you restart the video, you can check and make sure that to get 25, you could square 5 or negative 5. And to get 400, you could square 20 or you could square negative 20. So in general, to use this method, you want to rearrange the equation so that x squared is by itself, and then everything on the other side should be a constant value. So we have some number on the other side of the equation. We will then take the square root of both sides, and we don't want to forget that there is both a principal or positive root and also a negative root. We should have two solutions unless we are taking the square root of 0. Okay, so let's take a look at this first example. I want to get x squared by itself, so I will move the 1 onto the other side, and I get x squared equals 25. Now I'm just going to take the square root of both sides. Don't forget that I need a positive and negative square root. So I have x equals the positive or negative square root of 25, which means x equals 5 or x equals negative 5. And let's just try one more example before we move on to the harder, more complicated completing the square method. Here I have 3x squared plus 7 equals 55. I want to get x squared by itself on the left. So first I'm going to subtract 7 from both sides. I get 3x squared equals 48. Then I'm going to divide by 3, and I end up with x squared equals 16. So you can either at this point employ your mental math and just say that x is 4 or negative 4, or you can take the square root of both sides and you will get that x equals the positive or negative square root of 16, which means that x equals 4 or negative 4. And we're going to use this same method when we do the complete the square idea. It's just going to be a little bit more complicated because we won't have an x squared by itself. We will have those nice perfect squares that we created in the first part of the lesson. Okay, so in our third part of our lesson, we are using the full complete the square method to solve quadratic equations. We are going to first set up our equation in the form something x squared plus something x equals a number on the right. Then we will complete the square on the left side of the equation. We will then rewrite our perfect square in factored form, something squared, and we'll combine like terms on the other side. And then finally, we will take those positive and negative square roots of both sides and finally solve for x to find our two solutions. So let's take a look at our first example. In our first example, x squared minus 10x equals 4. Well, we already have our setup of something x squared plus something x equals some number. So that's great. My next piece is to complete this square. So I'm going to make a little area model off to the side here. Okay, I've got my x squared in the top left corner. I'm going to split that 10x into negative 5x and negative 5x so that these sides are the same length and that I make it a square. So now I have x minus 5 on the two sides, and negative 5 times negative 5 completes this square with a 25. So now that I know 25 is that magic completing the square number, I'm going to add that number to both sides. I'm going to add the 25 to the left to complete the square, and then to balance the equation, I'm also going to add it on the right. So my equation now looks like this. X squared minus 10x plus that 25 complete the square value equals 4 plus 25 to balance the equation. And now I am ready for my next step of rewriting the left as a perfect square. So to write something as a perfect square, in my parentheses, I need the expression that when I square it, I get x squared minus 10x plus 25. And that expression from our area model over here is x minus 5 times x minus 5, or x minus 5 squared. On the right, I now have 29. And now I'm ready for my next step of taking the square root of both sides. So when I take the square root of the left, I just get x minus 5. When I take the square root of a perfect square, I just get back what I started. However, on the other side, I get the positive or negative square root of 29. And then my last step to solve for x means that I need to add 5 to both sides. So I get x equals 5 plus or minus the square root of 29. And you'll notice that again, just like we did in the quadratic formula, we get that plus or minus here to give us our two answers. And in this case, we will have, if we use the plus, we get 5 plus the square root of 29. And if you plug that in your calculator, that's 10.39. And if you plug in the 5 minus the square root of 29, you get approximately negative 0.39. As always, if you'd like to plug your solutions back in and make sure that they make the equation true, you are welcome to. Just keep in mind that we rounded these, so the answer will be a little bit off. So let's try a second example. Here we have x squared plus 8x plus equals 20. And there may be another method that's better for this one, but we're going to try it with complete the square anyways, just to see how it works. So again, I'm going to make a little space in here, x squared plus 8x plus whatever number completes my square equals 20 plus that same value to balance out the equation. So in my area model here, I have x squared. I need to share that 8x in both of the linear term boxes here, 4x and 4x. So x plus 4 times x plus 4, that gives me a 16 as my complete the square number. So I have a 16 that I am adding to both sides of my equation. Next, I rewrite the left side as a perfect square. So what squared gives me x squared plus 8x plus 16? Well, x plus 4 squared gives me that expression. That's where I got the 16 from, is from squaring that x plus 4. And on the right side, I have 36. So now I'm ready to take the square root of both sides. Taking the square root of the left just gives me x plus 4. And taking the square root of the right, we can't forget that we need the positive or negative roots. So that's going to be plus or minus the square root of 36, which means x plus 4 equals plus or minus 6, positive or negative 6. And now, my last step, solving for x, I am going to subtract 4 from both sides. So I have x equals negative 4 plus or minus 6. And now I need to figure out, well, what happens when I add and what happens when I subtract. So x could equal negative 4 plus 6, which would give me a positive 2, or x could equal negative 4 minus 6, which would give me negative 10. And if you'd like to go back and try to solve this problem by factoring, you will actually get exactly the same solutions, because the solutions are the same no matter which method you use. So feel free to go check that using a second method. But negative 10 and positive 2 will make this equation true. We have one last example, and then we're going to wrap it up by talking about when to use each of the different methods. Okay, so we have done a lot of solving quadratics this week. We talked about a bunch of different methods, starting with factoring and using the zero product property. We then learned how to use the quadratic formula, and then finally how to take square roots of both sides and to complete the square and take square roots of both sides. So here's just a little table for you to try to figure out when it's appropriate to use each method. And there's a little bit to a caveat to this table. The one thing is, if we can use the method x squared equals c and take the square root of both sides, then we don't have to set it equal to 0. We can just solve using take the square roots of both sides. However, in any other situation, your first step will always be to set equal to 0, and then you need to determine if the equation is factorable or not factorable. If it is factorable, generally the factoring and zero product property method are the fastest, and then you can always use quadratic formula or completing the square. So if it's not factorable, you only have those two options. And if it is factorable, it's usually fastest to factor, but you could also use the quadratic formula or completing the square options if you prefer them. So let's check out two examples where we would try to figure out what's the best choice as a method. So in this first example, we do have an x term, so we know that we're not in that square root of both sides situation. So I am going to set this equal to 0. I'm going to move the 8 over to this side because I want to keep my a value positive. So subtracting 8 from both sides, I get 0 equals x squared minus 6x plus 1. And I'm going to ask myself, can I factor? And when I'm asking myself if I can factor, I'm really saying, are there some magic numbers that multiply to a times c, in this case 1, and add to negative 6x, my b value? There are no numbers that multiply to 1 and add to negative 6, so factoring is out. I have an even b value, which means I could definitely use completing the square. And then, of course, I can always use quadratic formula. So at that point, it's up to you, whichever method you prefer. you can use to solve this problem. In our next example, we have a negative x squared. I'm going to move everything to the other side so that I have a positive a value. So I have add x squared to both sides, subtract 10x from both sides. And that gives me 0 equals x squared minus 10x plus 7. And now I'm asking myself, can I factor? Which in this case means, are there any numbers that multiply to a times c, in this case that would be 7, and add to negative 10x? And again, in this scenario, nothing multiplies to 7 and adds to negative 10. Factoring's off the table. I have an even b value, so I may want to consider complete the square, or again, I can always use quadratic formula. One example where I might want to choose factoring is if I had a simple factoring problem like x squared minus 4x plus 3 equals 0, and then I can easily come up with my factors, which is much faster than complete the square, and then my zero product property works in a faster way. So again, if I can factor, it's usually the fastest method. If not, I can choose between complete the square and quadratic formula.